let's give it a shot. Yeah. Okay. Sorry, I'm clearing my throat here. Allergy is quite bad this morning. I do have coffee. Hope y'all can hear. Hope y'all can. Okay. Let's organize some stuff here. Close this. Make sure we don't have any. We do have changes here. Okay. Let me tweet this out. Let people take their time coming in. And I'm going to get caffeinated. So if anybody's around has any questions or just wants to chat, go ahead. Oh, I need to change the title. It's not quite right. How's everyone doing this this fine morning or fine evening wherever you may be? I'm just going to be reading some docs as everyone's coming in. Oh, it should have had it. Give me a second. Oops. Oh no, it has it. It's just in the quote tweet. Sorry. Let's reply. Hey, what's up, Clockwork? I didn't expect you to be in the stream. I think yeah. Just to let people come on in, give them some time. What do we got on the agenda here? This is the right date, right? Yeah. Really? Okay. I had no clue. Yeah, unfortunately, while this is a fighting game development stream, it's going to be what happened to those Twitch URLs? I don't know. I don't know what's Mighty Sandwich URLs. Yeah, I mean, like we're kind of just getting the ball rolling on this, so not knowing how much people understand about how this stuff gets implemented, I'm just going really step by step by step. So it's kind of like it might seem really boring, especially if you worked on fighting games before. So I mean, everybody does things differently. I've worked at a few different companies, and the way state machines get handled, where am I? Sorry, how fighting game implementation gets handled is different depending on where you're at. So that's weird. I don't know why it's missing the URL Mighty Sandwich. Huh. Okay, let me retweet that out. I think what happened is I must have copy pasted the wrong thing. I think that's what happened. Yeah, it's all my fault. So hopefully we're good now. Let's see. We got a few people in here. Okay. Well, I'm just going to go over the agenda real quick. Last time, this is a review real quick. So last time, we just did a quick design, a high-level design of like how the state machines are going to work, right? Effectively, the character, in the most like general sense, is going to go from an idle state, which is either standing, crouching, jumping, walking, whatever, to an attack. And once the attack is finished, it will return to an idle state or potentially go to a reaction. Reaction being hit stun state, block stun state, whatever. Same with idle. You can go from reaction, and once like hit stun is in this case, I just wrote the event as on stun, but this can be a event that fires when the block stun is over or the hit stun is over, and returns the idle. But the other thing is you actually can go back to an attack as well, because you don't want to pass through the idle state first, because that might incur a 1-frame penalty, basically 1-frame latency, and then frame advantage would not work the way you would expect it to work, right? If you have 5 frames of recovery and your opponent's attack is let's just say it's +0, that means you both can act at the same time, and if you both press that jab button on the same frame, assuming there's a buffer, or if you do it precisely, and both of your jabs are 5 frames or 4 frames, whatever, if it's the same, you should trade, right? If you were to go through idle state first, that effectively would add a -1 to your frame advantage, or subtract 1 from your frame advantage, and you would get hit if you were in the blocker hit state. Okay, and then of course I just broke down a little bit the idea of like, okay, idle is actually not a single state. It is multiple potential states that you go into, and depending on your input, you would either, if you went from, say you're in idle, crouching, whatever, standing, you would go into either standing jab, kick, whatever, blah, blah. These are not actual states we're going to use, but these are just kind of more concrete examples. And yeah, it basically works the same as the last diagram, but I just kind of broke down these general states into more specifically. Okay, let's see. But we actually never got around to coding, so today that's the idea. I'm going to start programming these. I spent the last 2 days or so looking at how I want to implement them in Zig. Zig being a language that I'm not entirely familiar with, I need to do a little bit of research. Okay, and with this one more thing, right now we do have some basic input control that moves like a ball around the screen. That's enough to test states, but we kind of have to infer what's happening there. There's no animation, anything like that, so it's not going to be exactly obvious. Say, for example, we're doing an attack. So for now, I'm going to use the Zig test feature to precisely or exactly unit test these transitions. Well, I don't know if they're actually unit tests, but we can verify these transitions work in code. Not entirely exciting, but we'll be getting there. Okay, so one more thing, actually. I found out recently the Compiler Explorer does have a Zig compiler, so if you want to test code, you can just come up to godbolt.org and just start coding away. I think this is a good way to like check if something works without having to pollute your code base with a bunch of tests. So, well, not tests, but just prototype code. And you probably can see here, I was just testing to see how I was going to handle state machine. But we'll go from here. Okay. Yes, it's Choundry. I will be uploading this to YouTube. Oh, and one more thing before we really get started. I do want to share our Discord just to keep up things. We don't really chat too much in there, but if you do have questions about game development, fighting game development, come on through. I'm pretty happy to answer any questions. Let's see. Let me get that invite link. Okay. Let me paste it in the chat, and we should be good to go. Hi. Well, thanks for coming by. I appreciate. Happy to have you. Okay. Alrighty. Let's go back to our code here, and then I show we have the agenda here. So last time I started working on this source file. Let's see what it is. It's called standing state main game simulation. I think I decided I'm not going to split the states into separate, at least for our base states, I'm not going to split them into separate files for now. If we look at our project layout, right, we have source, action states, standing state. For now, what I'm going to do is make well, I'm just going to rename this, actually, for now, so we don't have to do anything. And we're going to make this common states for now. And do we include it in here? Yeah. And of course, anybody who has any questions, just feel free to ask at any point. I'll try to pay attention to the chat as much as I can. There is a playlist for rollback. There is a playlist on YouTube for the Zig fighting game. I think I've been correctly updating it. Okay. Well, yeah. So you probably saw I had some test code going here. I'm just going to retype it out manually so you guys can see or follow along. Give me a second here. I want this on this side. Give me a bit. Okay. So the first thing we're going to do is implement our base state struct. What's going on? YZig. YZig. Oh, yeah. Okay. So, well, anything about C++ for one. C++ is the language I use for my day job, and it is the most common language used in game development for console games. That being said, it has a lot of pitfalls. It has a lot of foot guns, and I want to avoid having to explain those foot guns to everybody who's not necessarily familiar with C++. And I'm always down for learning new things, especially new programming languages. And I've been interested in Zig and Odin for a long time. Well, not necessarily a long time, but as of late, I've done a few projects in Zig just as tests, and I just liked it. It's for me, it was like, well, I don't want to do C++. I could potentially use C, pure C, because it's a much more simple language. But Zig is a language that is touting itself as a C replacement. but it has a lot of the nice modern features you would expect from a new programming language, such as non-nullable pointers, things like that. It has a more modern syntax for types, where you have a type as a postfix, not a prefix. It's a lot of the things people are becoming more familiar with newer languages. So okay, Zig is like C but more modern, so I'll go with that. And it has things like built-in tests. It has a built-in build system using Zig itself instead of a third-party language. So it was pretty easy to get set up as well. Yeah, Swift also seems to be one of those modern languages that are kind of a is it kind of a C or C++ replacement? I think that's like Apple's thing they want to replace or have replaced Objective-C, right? Yeah, Rust seems to be much more of a C++ replacement as far as I can tell, not necessarily a C replacement. So it has a lot more features. I think Zig, the idea with Zig is it's something you can like learn if you really want to. You can learn in like an afternoon. You can learn all the syntax. Okay, especially if you're coming from something like C. Alrighty. So yeah. Hey, what's up? What's up, Crazier? Alrighty. Okay, let's go. So let's just make the base. Well, there's not really inheritance here, but so the way we're going to handle this, I'm just going to start coding in this file, and we'll break things out if we need to. Okay, so the idea is we're going to have enum of our common base states, and then any unique states to a character, like their attacks, will be a unique identifier that are values that are larger than the last enum value, right? So I don't know what we're going to call this. We're going to call it, let's just say combat state. Okay, and I'm just going to make this a U32, unsigned 32. And what are going to be our base states? Okay, for now, standing, walking, crouching. We can reorder these later. Back up. Well, let's just say walking, walking forward, walking backwards. Jump. Okay. And for now, we're going to add more states later. There is a feature in in Zig called non-exhaustive enums. This just means, yeah, there could be more enums at the end. Okay. And so yeah, identifies okay. That's going to be that for now. And we're going to have to we have to make a structure that stores all the events that our states will be handling. I think I mentioned this before, but basically when we transition to a state, we're going to have the state initialize the character to, well, it's going to have to set various things up so that the state can correctly execute, such as setting the animation for an attack and such. So anyway, we'll have to do things on exit and on tick as well. So for now, on tick being something that gets executed every frame in this case, which hopefully we won't do for most things, but we'll get there. Okay, so let's just, what are we going to call this? Our set of interfaces, right? Let's call it yeah, let's just call it, I've called the things action states before. So for now, we need to have consistent naming here. Let's just say comment callbacks. I'm going to change this later. It's not important what is named. Well, okay, I shouldn't say that. I believe naming is important. It lets us talk about things very precisely. But I think this is understandable. Okay. Oops, and then this actually needs to be a struct. Okay. And what are our callbacks? Okay, we're gonna call it on start. This is just the defining the type. We're gonna have to add a context later, but don't worry about that for now. It's not defined, undefined. We're gonna have an on update, which will be called a reframe, called and on and okay. So yeah, so this is basically our interface. Let's see. Um, what are we going to call this? We're going to say okay. Anyway, so he provides interfaces for states to respond to various events. So let's call them combat states for now. Okay. And as you saw here, we had stuff like this, but this is not how I'm going to do it now. Once I start coding, I might get pretty silent here. So I'll do my best to try to describe what I'm doing. Okay, so I kind of already prototyped this out. So for example, how are we going to handle this? We're going to get rid of this here, and we're going to start on our standing state. So how will this get done? Well, for now, we're going to make a new structure for each state. We might change how we do this later, but this is how I'm going to do it for now. And we're just going to define the functions within the structure. Okay. So for example, the standing state would be like on start is going to be our function, and it's going to have the same signature. It's going to have the same type as the interface that we provided above here. Now, if there's any Zig programmers out here who knows a better way of doing what I'm doing here, or way you think is more appropriate for Zig, just please let me know. I'm learning on the fly at this point. Okay, so the idea is we're going to have the interface defined by this struct here, which will get filled out, and we're just using struct here as kind of a namespace. Again, if there's a better way to do that where I don't actually have to have a struct, please let me know. Okay. Let's see. So yeah, just for now, let's just use a debug. Setting everything that's undefined is a little weird. I'll get to why that is here in a second, okay? If there's a reason, is there any way to not to do that? Let me know. Yeah. So basically, I'm going to have a registry of states, and it's just going to be a static array that's going to be uninitialized at first, and then we're going to register each of these states one by one. So is there a way to provide an interface where you don't have to have like this kind of setup? That'd be awesome. Yeah, I prefer obviously not to have things undefined like this, but yeah. Okay, I mean, you can provide interface as a signature. Maybe there's some compile time stuff that's better, right? But I'm just not, haven't got there in my learning of Zig yet, so yeah. But I will continue with this general concept, and we can come back and correct it later. Okay, so yeah, we can just, for now, let's just include, the center library so we can do some debug printing, right? So we can do, let's see, okay, right? And then we can do the same for an update. Oh, we need a line break here. And then do it on N2. Cool. So this is going to be the basic setup of a state, and then what we're going to have to do is we're going to have to register standing along with the enum here, the reference to it. Let's do one more state for now, just so that we'll have a transition. Let's do crouching. Actually, and this is called standing state and crouching state. Okay. We might want to change the names later, but anyway, yeah. Well, let's just undo that for now, and so I don't have to do this. Okay. Awesome. So we have the our state set up here. What I want to do is, give me a second here. We will have, so yeah, Necromancy Black was asking if we're going to have unique states per move. There will be basically in memory, yes, but there will be common functionality. My plan is to have common functionality those states call into. Yeah. Before we start adding a lot of abstraction, I just want to make the state machine very explicit, if that makes any sense. Okay, where are we at? Let's see. So again, we're just implementing these functions inside of struct as a namespace effectively. Okay. We're going to refine the code here. So we're going to have to like register these states with some kind of manager that we can pull the states in when we're doing a transition, right? So let's add a new file here. We might rename this file structure here, but yeah, let's just call it state machine manager. I don't really like do that. What should we call it? State machine processor. Okay, let's call it state machine processor for now. Okay, and what will we do? Okay, we're going to have to implement a few different things. So the state machine is manager processor is going to have its own registry of states. So let's do this. Let's just call it state. So let's give me a second here how I want to handle this. Let's rename this. Let's just call this the state machine module or whatever. And then let's implement a register here. So I'd be careful here. I want to be very. I realize I'm not being consistent with the way I'm handling this. So I know it's common for Zig to have same line open curly brackets, but for me it's very much a habit of doing the next line. So I'm just going to stick to that for now. Okay. So registry is going to store an array of all potential states that a character could have. And hopefully I'm doing this correctly. So for now, we're just going to assume there's going to be max number of 255 states, right? Or 256, whatever. Let's just say, Yeah, let's just say the max number of states is 256. Let's see. Okay, and then so the state array is going to be size max states. I've already done this already, so we're gonna for now we're gonna have an optional pointer that we're gonna to initialize the null, so that because we're gonna have to register these states later. Maybe it's better to have an explicit struct that has the current registration state of one of these actions, but for now, let's put that off. So I call it states here. I don't want to get too abstract, so I'm gonna stick to calling it combat state. Because it ends up getting, when you start saying the word state all the time, it becomes unclear what we're talking about. So I'm gonna try to stick with combat state for now. Okay, so this question mark here, it makes the type an optional type that we can avoid having. I think is the way to avoid having nullable pointers. So a type safe. Well, it's a way to have type safe nullable pointers, as far as I understand. Okay, because if we just did this, we couldn't set it to null. So actually, let me think about this. How do we want to do this? Do we actually want to use pointers here? You know what? For now, let's not use pointers. Okay, let's not use pointers. Let's just have a flat array of action states. So this is make things simpler. Okay, so we can't make it const though. That's the only thing. Okay, we're gonna stick with my original plan. I'm just thinking of other potential solutions. Okay, so what we're actually gonna have to do is move this to something else. Yeah, okay, let's move this to here for now. And then so now we can have our combat state callbacks. So this array of combat state callbacks. They're all going to be initialized to null for now, because it's going to be a pointer or optional pointer. And we have to do this weird thing here where it's like duplicating it x state number of times. Okay. And then we're going to have state count, which is the number of states currently registered. Yeah, and then we're going to need a function for registering these states. So if everybody's following along well enough, we're going to pass in ourself as a pointer so we actually can make changes to the struct itself and not a copy. What did I do back wrong here? Oops. It should have been. Oops, yeah, I messed up here. Hold on. I messed up here, sorry. So it needs to be an array of optional pointers. Okay. And yeah, it is, sorry. Right, yeah. I forgot the const. You're right, I forgot the const. Pretty long line. Let me expand that a little bit. Okay. So yeah, when you're writing the type multiple times, it starts being like confusing. Do I actually need to write the? Well, I technically don't need to write the type here, right? I can set it to equals, maybe, or maybe it's better to have it explicit. Okay, okay, got it. Cool. So right. So we're gonna pass in the state registry into the function. This is just self is gonna be it's just syntax sugar is gonna be passed in automatically. Okay. And then what we need we need to pass in a list of functions that we're going to use for callbacks for the state. And I think it's fine if we just pass in a copy, right? Let's see. Actually, and we want to pass in the enum, so we want to pass in the enum. So state ID. I call it combat state ID. So what we're gonna have to do is we're gonna have to provide, of course, the registry, the enum, which references the combat state, and then the callbacks. We do not necessarily copyright, so the compilers can decide whatever is faster, I guess. And we want to make this const, right? Or does that not work? What's wrong with that? It's const by default, or const only used with pointers. Gotcha. Okay. Thank you for helping us out here. Cool. That's something to remember. Const parameters are always const. Great. Okay. What is going on here? Oh, sorry, we forgot void. So this needs to be void. Okay. So another long type signature. So basically, what's the idea is we're gonna take the states, the states and register into an array, right? So what's this extra one I'm gonna do? We're gonna do. Actually, we might not even need. So I haven't decided exactly how I'm gonna do this, but for now, what we're gonna do is not do this. Well, because we can't really iterate over all the states because we may not register them in the order. Okay, so actually, there's gonna be two different registers for now. Sorry, I want to have a common registry and a different one. So I want to have this is called register unique state, and we're gonna return a usize. And we're gonna have to have a reserved offset for the unique states. Anyway, is there a way to do like last common state equals jump or something like that? Does that work? Is that a thing you can do with enums? I'm sorry. What I'm trying to do here basically is I want to know what the last state, common state is within the enum, so that I can use numbers after the last common state to register new unique states per character. I mean, that's the idea right now. Sorry, I'm jumping a little bit over the place. You can use reflection to get the size. Okay. Gotcha, gotcha, gotcha. Okay, so I don't need to do anything like this. Okay, we'll get to that because I don't know precisely how to do that yet, but we'll get there. Awesome. Oh, thank you. You didn't have to go out of your way to do that, but it's much appreciated. So for now, we're going to talk about registering the common states. So we're going to have the state ID, and we're going to have the callbacks. What we're going to do is and actually I'm gonna get to something here real quick. Just give me a second. I want to add an assert, but I'm not sure what the assert syntax is. So basically the idea is we're going to make sure that, well, what we really want to know is, since we know this is going to be a common state, we're going to make sure the state ID, right, is going to be less than or equals to the last common state, but I don't know what that is right now. So we'll get to there. Okay. But this is the idea. We want to start on this. And asserts are used a lot in game development because it lets us catch things during testing without having to have the overhead of testing things in release builds. Okay, so we see assign this to the past and state callbacks. Okay. I do call this state callbacks here, but we might have other things we register within the state struct itself. So for now, I'm just going to call it this. Okay. And this is not going to be, this is actually going to be unique state count. Or actually I want to do this. Last unique. So the thing I really want to do is, let me just comment this out. What I want something like last unique state ID, and I want it to be equal to like the most recent ID we registered. But we'll get back to that at some point. We're just going to go over the common states for now. I think because of time-wise, we might have to do the unique character states on a next stream. Yeah, that's what it's looking like right now. Okay, so we can use this meta thing. I'm just gonna spitball here because I don't know. So something like okay, I'm just gonna leave this here for now. I'll get back to it just as a reminder. Okay, let's see, actually, yeah. Okay, so this registers our common state. Great. And so the next thing I want to do is so we're going to need the state machine, right? I'm still thinking in a very object-oriented way, which I'm trying to get away from, but let's just do this for now. And we'll correct it later. So we're gonna have to have actually our state machine processor. So state machine or executor, I think is better. Okay, this is thinking very much of a You know what? Let's just call it a state machine. Okay, for now. And well, state machine dot state machine. Shortened to state executor. Okay. And we're going to have our combat registry here. And for state registry. And hopefully the defaults, things can default to whatever it needs to default to. And we're going to have, actually we're writing a lot of code without even trying to compile this. So before I do that, let's see if this even compiles. Might have to get some more coffee or something here soon. Oh, yeah, if you ever come to Japan, the cheapest coffee to get is 7-Eleven or any of the convenience. They have a machine that makes it fresh, so it's definitely my go-to over things like Starbucks. Okay. Main, there's an error in main. What is it? 11. Oh, because I had all this stuff here. Let's just get rid of this. Just want to fix compile errors real quick. Main.zig. What is it? Oh, I still had some code left in. What did I do? Wait, what? Oops. Did not save. Let's get rid of this. Okay. Yeah, let's get rid of all this code. Just to double check I didn't have anything. Yeah, the other junk in here. Okay. Going back to the code. So I forgot, I did not actually include, well, I think we did include the common states into our game simulation. I didn't include our state machine module, so. So maybe this will actually won't compile. How are we doing on time? Okay, we've got a few more minutes. Yeah, that's what I thought. Oh, this should be callbacks. Got it. With a K. I thought I deleted that. So what is that? What's happening here? Did we get out of sync somehow? Wait. Okay. I got it. I know what happened. I forgot to close the window, so the old errors are still there. Okay. Oh, comment state registry. Okay. Got it. I'm curious, Johnny Marler, as far as like tests go, because I do want to implement a test here. Do we, in Zig, is it common to implement tests as separate, in separate files, or is it often done in the same source file? I'm just curious about that, because for what I could tell, it looked like often they would put the test in the same source file. I think from reading some of the standard library stuff, I need to go back and check. Okay, what do we hear? Okay, small test, same file, got it. For now, I'll put it in the same file, and we can move it later. Let's see. Oh, that again. Okay, cool. It compiles. Great. So before we make the actual state machine processor, I want to test this code just as an example of how to do tests. So I was looking at the documentation here. So we basically give a test, give a name, and then a condition. So I want to try that. So basically, let's call it test. Register combat state. And then we need something like this. Expects, right? So what I want to expect is after we register. So okay, let's make a combat registry. And then okay, so we have the combat registry. What was the problem? Oh my god. my brain just goes wow. Back to C automatically. It prints the values when it fails. Oh, okay, cool. So expect equals. So expect equal like that. Okay, I'll just leave that here for a second. Okay. The test needs semicolon. No, they don't. Okay, I'm just making sure we don't have syntax errors here. Yeah, this is a var. Okay. More coffee in my system. I got to build up those habits, those zig habits. So I can just type things. Okay. So it must be initialized, and how do we initialize it? Just like that again? My brain, man. I'm just gonna go back here to our code. It's a dot syntax. Okay, got it. Just get back in the habit. Hopefully defaults work. This is actually part of why I want to do this, because I want to check the defaults. Okay, cool. So that's not an issue. So what we need to do is actually registry dot register common state, and so the way you're doing is a better way to do it, actually, or I think it's more precise, more concise, not precise. Okay, yeah, let's do that. As always, thank you for your help, Johnny Marley, guiding us through the Zig way of life. But yeah, this is just clear way of writing code. Okay. Let's see. Okay, we want to register common state, and we want to register the ID. So let's say standing, right? So we want to register. What's the enum? Common state ID. So we're going to register common state ID. We're going to do standing. And actually, what we're going to have to do is we're going to have to create. I'm going to get around to doing this maybe better, but we're going to actually have to initialize our standing state to something. So, oh, I forgot to include standard. Okay. I forgot to include the standard. So, what I'm going to do is, we could import this, but I don't want to import this into our state machine. So what I'm going to do is define the struct here. Can I do that? This is called test. Oops. Maybe, yeah. We don't really need to do any of this, actually, but because we don't actually need to implement the functions. Well, actually, we don't need any of this, to be honest. what we can do though is, because we're not even testing for that. What we're testing for is just registering. So we can just have a, I think we can do this. Give me a second. Yeah, we can just have a blank. We can just have that, right? No, I just realized something that I did here that I didn't want to do. So we're storing pointers, and I wasn't explicit about that here. So why does this work? I'm confused. So this is a array of pointers, and I was able to assign this. Is it automatically get converted to a pointer? Because my instincts from C++ is that we're getting away with something that is syntactically correct, but it's going to lead to a pointing to invalid memory. Or does this actually work? Is it better to be explicit? My hunch is it's better to be explicit about that our parameter is a pointer. So something like const. Yeah, I mean, it did compile somehow. But anyway, we weren't using it yet. So give me a second. So I don't want to do this. I want to have... okay. But yeah, I just want to register this and I want to test if this is actually assigned. So, sorry, I'm copying some code here. Where's our registry? Combat states. So combat states. So we want to test precisely one thing, right? So we're testing to see if this is actually assigned. And my understanding is, since this is optional, this should only, or should we do this? Is there a way to test an optional like this? Like what I want to do, I guess, is, what do we do? When OK is false, the test fails. Yeah, sorry. I didn't want to do this exactly. I just want to test to see if it's set. So something conceptually like, how to put it? Registry.combat states 0 is assigned. Oh, this equals null. So that's something we can do. Well, no, not equal to null. Sorry. Not equal to null. That's what we're expecting. Or so really what we're expecting is we're expecting this to be equal to null here and then not equal to null after the change. Is what's really going on here. On line 40. Oh, you're right. You're correct. We should have a we need the address, right, so to speak. Okay. Let's see if that builds. Oh, I do see an error here. I don't know what that's about. Okay, it builds. So now we've written the test. It syntactically allows it to compile, but I want to actually run the test. And we haven't set up any way to run tests yet. So, did the build script it generate give us a way to run tests? Okay. Okay, it's so we have a run step or exa step. Yeah, we could do that, but well, that is, I mean, give me a second here. Okay. Does it show which test it ran? Failed to write cache manifest. Oh, it's fine, I guess, but so because in our build script we have test step. Do we have to manually add the tests for each file? Ref all DL. What is that? Okay, I'll add that. Because I don't think we have it yet. Or oh, we do have it. Oh, okay. I guess it got generated. I didn't even notice. Thank you. Let me add that code. Again, I apologize for my bracket style, but it is something I have habit doing, so I will stick to it for now, so I don't get mixed styles all over the place. Okay. Okay, does that run now? Area Client identifier testing. Oh, I know what happened. It needs to be standard.testing, right? Yeah, sorry about. There's a little bit of delay in the stream, of course. So I think by the time I realize what it is, you've already corrected me. Okay. What happened here? Hold on. Oh. I'm gonna find raylib. Where is that at? So we couldn't find raylib. I guess that's because of the way the build script is set up. Yeah, again, I apologize for people who are not here to see how unit tests are set up, but I do want to use unit tests or just tests in general to to test the code before we get it running. It's going to save us time in the long run. Comment out your raylib import. Well, I can't. I mean, I can comment it out for now to test the code, right? But well, I didn't. Yeah. Okay. Is there a way to run tests on a specific source file? So I'd have to add that to main, like import like, what is it, action states? Sorry. But that would also import it during builds, not just test, right? So sorry, I'm gonna have to look this up. Oh, so you can just run zig test on a specific file. So I could just do zig. Wait, hold on. Oh, I gotta try. Okay. Gotcha. Size. Okay. I need a usize. State ID is not usize, so I need to convert. Was it enum? Can I do enum to int? Does that work? I'm playing about that. Okay. Looks like all tests passed now. Okay, as long as I'm not importing anything outside the files path, it works. Gotcha. Okay. Sweet. So the tests work. I wanted to get around to doing transitions and stuff today, but it's kind of crazy how things take longer than you expect when it comes to programming, especially when you're learning a new language like we are here. But yeah, we're gonna have to split off this one into a two-parter at least. So yeah, at least we have the idea how to run tests, the general idea of like our interface for states, but the actual state machine processor won't be nearly as involved. It's pretty simple. Yeah, so I'll just clean up this code and submit it so people can take a look on GitHub. And other than that, if there's any questions in regards to what we did this time, sorry it wasn't a lot of progress, but you only can do so much in an hour. So I'm hoping I can get more time to do like maybe 2-hour long streams at least on the weekends. We'll see. But yeah, I'll stream again tomorrow since we have a direction for where we're going. I'll stream again tomorrow morning, and we'll finish off the state machine stuff. Yeah, I mean, there's so much I want to discuss about state machines because like pretty much like as game developers, you're living in state machines, right? It's like state machines all the way down. Because you want to be very explicit. You want to know, not to overuse the word state, but you want to know what state not only the game is in, but what state explicitly, especially in a fighting game, a character is in. So you can see what's valid, right? If you're jumping, you want to make sure, obviously, things like accelerations being applied, etc., etc. Yes, it is tricky. We can't technically. I mean, if you really want to be precise, programs are defined by every single bit that's stored in memory, right? We can't truly exhaustively enumerate every single state, but as far as like behavior goes, well, we can do a lot. Yeah, I'll put it that way. but we can't enumerate everything, but we can be a lot more precise with our intent using state machines, I guess is the way I want to put it. Like, we technically don't have to be explicit with our state machines or state machines to make a video game, right? You can just manipulate variables uh, and without even thinking about the high level state that you're in, right? But it is incredibly useful when we're making something like a character controller to be like, oh, you're currently walking, the character is currently attacking, that kind of stuff, right? The game itself is currently in, maybe it's in super freeze, things like that, right? These kind of explicit states helps us avoid bugs, and in code it lets us show our intent. So maybe in the future we're coming through trying to figure out what's going on with a bug, and we're like, well, we need to make sure that we're like, oh, okay, we're the character's actually maybe in a throw lock state or something, right? And then we could find, okay, where did that transition happen? Why did that transition happen? Where are the condition variables? Where the transition variables, variables that led to the transition, things that we're expecting to be set when that transition occurred, right? When it comes to like software development, I hope, well, I desire as much as possible to be explicit, and I want code to show intent, right? I don't like implicit behavior. Obviously, we can't entirely avoid it, but we do our best. Well, yeah, anyway, that's pretty much all I have for today. We'll get back on continuing the implementation of the state machine tomorrow. If there's anything anybody wants to chat about or any comments, just let me know. I'm just going to look over my changes real quick. Well, that's not there. What are all these? Are all these? I need to add this to my ignore list. These kind of files. Looks like there's a bunch of cache stuff that were generated. I need to ignore all folders that have like zig cache. Anyway. Oh, well, Drega, that's great. I'm really happy that it's going to gives you something to chew on, I guess. We don't make very fast progress here, but I hope during every stream we make some progress, step by step. I think, all of us have a unique path when it goes through game development. So we develop our own heuristics about the best way to do things. But it's always good to reevaluate how you're doing things, especially when you can see somebody else trying to do things that you've done before, but maybe in a different way. It lets you go, okay, oh, this is how another person does it. So it either gives you confidence that the way you're doing it is correct, or maybe, oh, this is another tool in my tool bag now, right? This other person thinks in this way, and this is how they draw their own conclusions based on their experience and just reasoning things out, right? Because everybody doesn't necessarily reason in the same way and draw the same conclusions about, especially when it comes to engineering, what are the best choices, right? Because there's always trade-offs, and it's always down to the person to make a decision on whether or not this one choice is better for the particular program they're making, or let's just say, in this case, games, right? Okay. Oh, awesome. Yeah. Well, as always, I appreciate everybody coming by. It means a lot to me that you all are hanging out, not letting me just talk in silence here. But yeah, I hope whoever has the opportunity to come by tomorrow and in the future can come by and watch. If not, I will be uploading these to YouTube. And I'm going to just again paste our Discord link for anybody who's interested in hanging out and chatting, or whatever. It doesn't have to be about this game in particular. If it's interested in game development, come on by. But yeah, again, thank you very much. I hope everybody has a good evening. If you're out in Europe, I know it's pretty early for you. And if you're in Japan, well, enjoy the rest of your day, or anywhere else in out in East Asia. Okay, well, that's it for me. Again, as always, hope to see you soon. Goodbye.